So we're going to be doing a problem from the AP Classroom on optimization. So a rectangle has its upper two vertices on the graph y equals 12 minus x squared over 3, and its lower two vertices on the x-axis. What is the maximum possible area of the rectangle? So to start, let's draw a picture. So we can draw the axes, and the function y minus x squared over 3 is going to be a downward-facing parabola. The picture doesn't have to be perfect, we're just trying to get an idea for what to draw. So now the lower two vertices are on the x-axis, so we can draw a vertex here, a vertex here, and we can connect it to the top to make the rectangle. And then from there, we see that the base has a length 2x, because this side has length x, and this side has length x. So together they have 2x, that is their length. And then the height is whatever x is plugged into the function, so that is going to be 12 minus x squared over 3. So now we can make an area function. So the area is going to be the base times the height, and the base is 2x, and then the height is 12 minus x squared over 3. Okay, so from there, we can distribute. So 24x minus 2x to the third over 3. So from there, we want to find the critical points. So we're going to take the derivative of the area function. So that's going to be 24 minus 2x squared. And that is equal to 0, so we can find the critical points. And now we can divide both terms by 2, so 12 minus x squared equals 0, and x squared equals 12, so x equals root 12, which is equal to 2 root 3. So now we want to make sure that 2 root 3 is a local maximum, and actually in this case it's going to be an absolute maximum because it's the only critical point. So to do that, we have to take the second derivative of the area function. So that's going to be a double prime. We can just take the derivative of the area function to get the second derivative. So it's going to be the derivative of 24 minus 2x squared, which is the derivative of 24 is 0, and then the derivative of negative 2x squared is negative 4x. And if we plug 2 root 3 into this, we'll see that it is negative, so it is in fact an absolute maximum. So from there, we can just plug 2 root 3 into the area function. So that's going to be 2 times 2 root 3 times 12 minus 2 root 3 squared. And this is over 3. So after doing the math, we can see that the maximum area is going to be 32 root 3. And this is our final answer.